Now let's take the first question of this set. Here it says that in a rectangle ABCD, the diagonal meets at a point P and is the midpoint of BC. So a lot of scenarios given. So let us draw them. So I've already drawn. Here is the figure as you can see. So this is the rectangle ABCD and it says that diagonal meet at P. So we have drawn diagonal BD and AC, right? And the intersection point is P. Point E is the midpoint of BC. So for BC, this is the midpoint. So these two are equal, right? Here these two would be equal. Here these two would be equal because the diagonal, the intersection of the diagonal basically divides the diagonal or bisects the diagonal, right? In a case of rectangle, when it bisects, that means it divides into two equal parts. Further, it says that if the area of the rectangle is given to us as 24, we have to find the area of the triangle APQ. We have to find this, right? Now, a lot of equal line segments are given, right? Sides are given. So we have to apply the logic of median. How? First of all, ABCD is a rectangle whose area is 24. Clearly, we can see that triangle ABC, this will have an area which will be equal to half of the rectangle, which is 12. Why so? Because it is dividing the rectangle into two parts. The diagonal divides the rectangle into two equal areas, right? So the area of ABC would be 12 and the area of ACD will also be 12, correct? Further, if you look at point P, then we can say that in this triangle ABC, P is the median. So we can say that triangle, area of the triangle ABP, this will be half of the area of the triangle ABC, which comes out to be 6. With the same logic that BP is the median. So median divides the triangle into two equal areas, right? Now, since E is the midpoint of BC, then we can say that AE and BP, they are the median for the triangle ABC, right? The first median is AE, right? And the second median is BP. And it is intersecting at point Q. So we can say that Q would be the centroid. Now we know that the centroid divides the line or the median in the ratio of 2:1, right? You know that the area of the triangle ABP is 6. And here again, we can apply the rule that from the common vertex, this is the first triangle, this is the second triangle, the triangle AQP and the triangle ABC. Their area will be in the ratio of their base, and the base is in the ratio 1:2, and the total area is 6. So we can say that the area of this portion, that is be A, then the area A would be 1/3 of 6, which comes out to be 2. And that is the answer because we were asked to find the area of the triangle APQ. So option C becomes the right answer. Not a very difficult question, but yes, it will require some time to solve it. The reason being, we have to apply the same logic of median dividing the triangle into two equal halves multiple times. Now let's take another question. It says that in the figure given below, the angle ABC is equal to angle BC and both are equal to 90 degrees. So angle ABC, that is, this is 90 degree, and angle BEC, this is also 90 degree, correct? Now the length of AB is 15, the length of BC is 20, right? And the length of BD is equal to 12, and the length of CE is 16. So these lengths are given. So if you just focus on the triangle ABC, this is a right triangle. Why? This is a right triangle with sides 15 and 20. So we can apply the Pythagoras theorem in this triangle ABC to get the value of AC. On calculation, we'll be getting the value of AC to be 25. This is very, very simple to calculate, right? Now, the length of AC is 25. Further, this length BD is 12. Now, BD, if we closely observe this length 12, then we can find that if we calculate the area of this triangle ABC, which comes out to be half into base into 15, right? Which comes out to be 150, correct? Now, if I take the product AC, that is half of AC into BD, if I do this, then it comes out to be half of 25 into 12, which again comes out to be 150. That means the area of this triangle can be calculated by taking BC as the base and AB as the altitude, or it can be taken as AC as the base and BD as the altitude, because in both the cases we are getting the area to be 150. That clearly indicates that BD is nothing but perpendicular or the altitude on AC, right? This is the significant thing which we have to identify. Once we have identified, then we have to use Ptolemy's theorem. What is Ptolemy's theorem? It says that any cyclic quadrilateral, first of all, why or which cyclic quadrilateral I'm talking about? I'm talking about cyclic quadrilateral BDCE. If you just observe this quadrilateral, then this is cyclic quadrilateral. Why so? Because the opposite angle, the sum of opposite angle is 180 degree. 90, 90 plus will give me 180 degree. That means this triangle is a, this quadrilateral is a cyclic quadrilateral. Now we need to find the length of DE. That is, we have to find the length of diagonal of the cyclic quadrilateral. So we can use Ptolemy's theorem. We say that the product of the diagonal, that is BC into DE, is equal to sum of the product of the opposite side, which is BD into CE. This is the opposite side, plus BE into DC. I think we know all the values. We have the value BC, which is equal to 20, right? We have to find the value of DE. We know the value of BD, which is 12. We know the value of CE, which is 16. We know the value of BE, right? We need to find the value of BE. Let's see how we can find the value of BE. We can see that triangle BEC, this is also a right angle triangle. We know that the hypotenuse is 20 and one of the length is 16. So again, applying Pythagoras theorem in this triangle, we can find the value of B, right? So the value of B would be what? This is 5 into 4, this is 4 into 4. So this has to be 3 into 4, which comes out to be 12, right? This is 3, 4, 5 triplets. Multiple of 4 is going on. So BE is again 12 and the value of DC is given to us as nowhere it is given. So we have to find DC again. Let's see. This is dividing. This is 12. This is 90 degree. This is 12. This is 15. So again 5 into 3, right? 4 into 3. So this has to be 3 into 3. That is 9. So obviously if AD is 9, then this portion has to be 16. 25 minus 9. So this is 16. So just on calculation, we'll be getting the value of D as 19.20, which is option number B. Difficult question, I would say, because you have to apply, you have to find a lot of lengths and you have to apply Ptolemy's theorem also. For applying the Ptolemy's theorem, you have to first of all figure out that there is some cyclic quadrilateral being framed. So definitely the difficulty level is high. I'm not expecting that somebody can solve it in the test scenario, but yes, it's a very good question to practice. Now let's take the third question. Here it says that in the figure, ABCD is a parallelogram whose diagonal intersect at point O. Everything is given in the figure and E is the midpoint of side AD. So this two length will be equal, correct? Now the side BC is extended to F such that CF is half of BC. CH is half of BC. So let me assume that CF is X, so BC would be 2 of X. And we need to find this ratio. Whenever we have to find anything related to ratio, 99% of the cases we have to apply the logic of similar triangles. So we have to identify two triangles which are similar to each other, right? And they must include the side DH and BH respectively, correct? Now here, if we say that ABCD is a parallelogram, then AD will be equal to BC, right? So entire length will be 2 of X and E is the midpoint. So we can say that this much portion is X, correct? Further, since AD is parallel to BC because it's a parallelogram, we can say that EF is actually behaving as a transversal line. So alternate interior angle, that means this angle must be equal to this angle. Similarly, BD is also acting as a transversal, so these two angles will be equal. So if we clearly observe angle EHD and triangle FHB, then these two triangles are similar. I'm talking about this triangle and this triangle. They are similar, right? Now, if these two triangles are similar, then their corresponding sides should be in the ratio, right? And their corresponding side, if I take ED, then the corresponding side is BF, right? So ED over, in fact, we have to take like this, ED and FB, they are in the ratio of 1:3. Why 1:3? Because this is X and this entire value is 3 of X. So this is the ratio in which every corresponding sides will be, right? Now let us focus on DH. DH is this side. In fact, let us do here. DH is this, and correspondingly BH is this. So these two will also be in the same ratio. So we can say that DH over BH will also be in the ratio 1:3. So option B becomes the right answer. Simple question should be solved. It may take some time to identify the similar triangles, but yes, once you have identified, then it will be cracked. Now let's take the third question. Here it says that the side length of a rhombus is 10 and one of the interior angle is 120 degree. Then we need to find the area of the rhombus. So let us draw the rhombus. So this is the rhombus and one of the interior angle is 120 degree. Let us assume that this is 120 degree, right? So in a rhombus, we know that these two are parallel and equal, right? So this angle would be 60 degree, correct? Because the sum of these two has to be 180 degree. Now this length is 10, this is also 10, this is also 10, right? So what we can do here is that if we draw these diagonals, so these diagonals are D1 and D2, right? We know that the area of the rhombus is half D1 D2. This is one way, right? The other way of finding the area of this rhombus is if we ignore one of the diagonal, right? Let me just consider only this diagonal. Then we can say that this diagonal divides the rhombus into equal areas, right? Because both are symmetrical. So if I can find the area of this triangle, then we can add or multiply it by 2 to get the area of this as well. The addition of these two will be the area of the rhombus, correct? So we have reduced the question from finding the area of the rhombus to finding the area of this triangle whose one angle is 60 degree and the including sides are 10. So we know that the triangle in which one of the angle is theta and the other two sides are A and B, then the area is half AB sine of theta. Just comparing, we can see that the area of this triangle would be what? Half 10 into 10 into sine of 60 degree. On calculation, this will be what? This will go by 5 times. So this is 50 root of 3. So the area of this thing is 50 root of 3 and that will be the area of this portion as well. So adding these two will be getting 100 root 3 and that will be the area of the rhombus. Easy question. It can be solved in various other ways also. I have just given you one of the easiest way to solve it. Now let's take the fifth question. Here it says that P, Q, S and R, they are the point on the circumference of the circle with radius R such that PQR is an equilateral triangle and PS is the diameter of the circle. So let us draw the scenario. So here we have been given a circle, right? Let us first of all draw this triangle PQR because it's an equilateral triangle. So let us do like this. So this is an equilateral triangle. So this is P, this is Q, this is R, right? And PS is the diameter. S is another point on the circumference, right? So obviously PS, if it's the diameter, it will be something like this, right? So this is point S. And we need to find the perimeter of the quadrilateral PQSR. So we have to join them also. Now we have to figure out that, say this is the center, then we have to figure out that what could be the length of QS, what could be the length of PQ, so and so forth. Because of symmetry, it looks like that PQ and QR, QS and SR, in fact QS and SR should be equal, right? PQ and PR are equal because it's an equilateral triangle and that is also equal to QR. Now if you focus on, say, triangle PQS, then here we can say that this will be 90 degree. Why so? Because PS is the diameter, so angle in a semicircle is a 90 degree. So this angle is 90 degree. The same logic, we can say that this angle is also 90 degree, right? Now the triangle PQS and the triangle PRS both are right angle triangle, and here we can see that one of the side is equal and it has the common hypotenuse. PS is the common hypotenuse. So from the RHS properties, we can say that both are actually congruent. Both are equal triangles. Both are congruent. So the corresponding sides will be equal, right? Further, since this is 90 degree, this angle will also be equal to this angle because they are congruent. The complete angle is 60 degree. Why so? Because it's an equilateral triangle. So each of these angle will be 30 degree, right? Now just focus on this triangle PQS. This is 30, this is 90. So obviously this will be 60 degree. So we can say that this is a 30, 60, 90 degree triangle. And we know that the corresponding sides are in the ratio 1 is to root 3 is to 2, right? The corresponding side of S, in fact, the corresponding side for Q, because Q is the 90 degree here, right? Q is 90 degrees. So the corresponding side of Q is P0 or PO and OS, that is 2R. So corresponding side of 30 degree, that is QS, that will be equal to R, right? and the corresponding side, this will be root 3r. So we have identified all the sides of the quadrilateral. So this will be r root of 3, this is r, this is again r, this will be r root of 3. Why so? Because both are concurrent, so obviously the corresponding sides will be equal. So we have to find the perimeter, right? So we have to add all these four numbers. So it comes out to be r root 3 two times and r also two times. So this will be the answer. You have to just look for this 2 times of r root 3 plus 1, right? This option we have to look 2r root 3 plus 1, which is option number A. So option A becomes the right answer. Not a difficult question. Anyone who is good at identifying the symmetry, who is finding the angles appropriately, can apply this logic of 36 to 90 and get the required lengths. Now let's take the sixth question. It looks very interesting. Here it says that the rectangle DEFA is a 3 cross 4 rectangle with B sides equal to 1, and we need to find the area of this backplanes. Now, since this is a rectangle, we can say that these two are parallel, right? The objective is to find the area of the shaded region. So our process would be that we should find the area of CBFE, which is nothing but a trapezium, right? And then we'll be deducting the area of these two triangles. So whatever is left will be the area of the shaded region. This is the approach we'll be following. So clearly, area of this CBFE, this trapezium, will be half of sum of the parallel sides, which is 1, and this is 4. Sorry, this is 3. This is 3 cross 4 now. So this is 3. So 1 plus 3 into the height. Height will be 4 itself, right? Which comes out to be, this will go by 2 times. So 2 into 4 will give me 8. This is the complete area. Now, the area of triangle, say this point is O. We can see that triangle C or BOC is similar to triangle EOF. Correct? Why they are similar? Because this is the trapezium. So obviously these two lines are parallel. So we can say that this angle would be equal to this angle, and this angle would be equal to this angle, right? Parallel lines, transversal lines, alternate interior angles. So these two triangles are similar. So obviously their area would be square of their any corresponding linear dimension. So here we'll be targeting height. How? The corresponding base or the corresponding side CB, this is 1 here, and here the corresponding side is 3. So we can say that everything is going in the ratio 1:3. So their area, their corresponding area will be in the ratio of 1 square is to 3 square, which is 1:9. Also, their height will be in the ratio of 1:3. The complete height, if I add this height plus this height, this complete height is nothing but equal to 4. So we can say that the height of BOC is 1 itself, and the height of EOF is 3. Now once we have identified the height, the base is also known. The base is 1 and 3. This is the base, this will be the height. Similarly, this is the base, this will be the height. So the area of BOC, if I want to find the area of BOC, this will be half base into height, which is equal to half. And similarly, the area of triangle, this FOE, this will be equal to half into 3 into 3, which comes out to 9/2. So we have to add these two and subtract with 8. So on adding, we'll be getting it as 1/2 plus 9/2 will be 5/2, 10/2, which comes out to be 5. So their addition is 5. So the required area would be 8 minus 5, which is equal to 3, right? So 3 will be the answer. Here the options are incorrect. So let me just mark this as 3. So option C becomes the right answer. Now here the question says that ABCD is a rectangle and the value of BC and BC is given to us. So let us draw that rectangle. If this is a rectangle like this. So this is A, B, C and D, right? And the value of BC is A, so as the value of AD, right? And the value of DC is root 3 of A, and that will also be the value of AB, right? Because this is a rectangle and that these angles would be 90 degrees. Further, it says that the perpendicular drop from point A meets BD at point F. So we have to join BD. So perpendicular has been dropped here, which is meeting at F. So obviously this will be 90, this will be 90, correct? And the diagonal AC and BD intersect at point G. So if I draw diagonal AC, then this is the point G, correct? Now, what is the area of triangle AFG? So we have to focus on this triangle. Now, clearly we can see that this is a right angle triangle. Once we get the value of AF and FG, we can apply half base into height to get the required answer. Now, just focusing on the triangle ABD, or let's take this triangle only. Triangle ABD. Here we can see that this side is A, this is A root 3, this is 90 degrees. So applying Pythagoras theorem, we can get the value of BD. So the value of BD, which is the diagonal, is nothing but 2 of A, and that too would be the value of the other diagonal, that is AC, because in a rectangle both the diagonals are equal. Now, since G is the center point of this rectangle, in fact G will divide the diagonals into two equal parts. We can say that each of these values AG and GC, they will be A. Similarly, G is also dividing the diagonal BD, so obviously this value is A and this entire value would be A, correct? Now we need to find the value of say df so that we can subtract this value say x from A to get the value of fg, right? And we need to get the value of AF as well. Now let us focus on AF. If you just find the area of this triangle ABD, assuming that this is the base, AB is the base and AD is the altitude, then it will be half of root 3A into A. The other way of finding the area of the same triangle would be taking BD as the base and AF as the altitude. Then it would be half of BD is nothing but 2 times of A into A of F. So A of F, clearly we can see that this will get cancelled out, is equal to root 3 by 2 times of A. Right? So we have identified this. Now let us try to figure out what is the value of X. Now since AF is root 3 by 2 times of A, this is A, this is 90 degrees. So again applying Pythagoras theorem in the triangle AFD, what we'll be getting is that A square, that is hypotenuse, will be equal to AF, which is root 3 by 2 whole square plus X square, correct? So the value of X on calculation will be 1 by 2 times of A. So this is the value of X, this is AF. So FG, the value of FG would be equal to A minus X, which is nothing but A minus 1 by 2 times of A or 1 by 2 times of A. So we have identified that this is 1 by 2 times of A. So if this is the base, then this will be the altitude, right? For this particular triangle. So the required answer would be half base into height, which on calculation would be root 3 by 8 A square. Option D becomes the right answer. Not a difficult one, but at the same time I would say that not a very easy one as well, because you need to identify the triangles wherein we have to apply Pythagoras theorem. Now let's take the 8th question. Here it says that in the given figure, ABCD is a trapezium in which AB is parallel to CD. So this is parallel, right? Similarly, these two are also parallel, that is this is parallel to this. And the value of AP is given to us 4, DC is 4 and QB is 2, right? We need to find the area of ratio of area of triangle COD to the triangle AOB. Now clearly if this is a parallel, this is a trapezium, then we know that this triangle and this triangle will be similar. Why so? Because if these two lines are parallel, then DB being a transversal, we can say that this angle will be equal to this angle, alternate interior angle. Similarly, if I take the transversal AC, then this angle will be equal to this angle. In both these triangle, two corresponding angles are equal, so they are similar. Now if they are similar, then their area would be square of their corresponding side, or the ratio of their area would be square of their corresponding side. So for area of triangle COD, the corresponding side I am taking as DC, right? So it will be 4 square divided by, if I want to find the area of the triangle AOB, the corresponding side of this is nothing but AB, which is equal to what? This is 4, this will also be equal to 4. Why it will be 4? Because this is a perpendicular drop. So this is 90, this is 90. This is parallel and the interior angles are 90 degree. That means PQCD, this is a rectangle. I repeat, PQCD, it will be a rectangle. Thereby we can say that PQ would be equal to DC. So this is also 4 and this is 2. Combining all three, it will be equal to 10 square. So on calculation, I'll be getting it as this will be 16 by 100, or we can say that 4 by 25. So option A becomes the right answer. Very easy question. Anybody can solve it.